Good morning, everyone. My name is Anne-Marie Imafidon, and I am introducing this conference's Innovation Union lecture on the 21st century of an idea of a university. As per usual, we are going to be able to, or you'll be able to join the conversation on Twitter. I have an iPad down here for any questions that you're going to submit, so please do submit them. Now, I've always known that I was going to go to university, and I'm fortunate enough to have come from a family background where both of my parents attended university and placed a large emphasis and value on education and the importance of us achieving a degree. My first actual thought of how that might happen came to me age 13, when at school we were asked to do a career survey, which asked several questions. One such as, what do you like? What do you dislike? How do you work? Would you like to work outside? Do you like maths? Now, after answering this survey, came back my suggested destiny. Apparently, I was to become a management consultant. Now, age 13, I'd never heard of this job before. But after a little bit of research, I saw that if I went to Oxford University, I was 16 times more likely to get a role as a management consultant. A little bit more research also revealed the salary of management consultants, and from then I was sold. Within 2 years, I'd gained admission to study mathematics and computer science at Oxford University. And I didn't go up until I was 17, and I haven't become a management consultant. But I still maintain that my personal motivation to go to university, and Oxford in particular, was very much career-led. When I graduated with my master's age 20, the picture in the middle, that year, the youngest to have done so, I was ready to work, and I actually already had a role lined up. Now, when we look at the figures, my experience wasn't so typical. In addition to being at university so early, I was also a girl on a technology course. I was one of 3 in a class of 70. In the UK, the proportion currently stands at 18%. In Germany, it hovers at around 20%. And in the US, it's currently a staggering 12%, down from 37.1% in 1984. STEM is the known abbreviation for science, technology, engineering, and mathematics, and this range of subjects which rely on a knowledge of the sciences. Now, parity has been reached in medical sciences, biology, veterinary sciences, everything that has to do with humans and animals, but we have not had the equal representation within the physical sciences, those that are perceived as more masculine or geeky. Engineering and computer science in particular. Now, a couple of years ago, it would have been acceptable to say that women simply aren't as good as men at the sciences and mathematics. Worldwide PISA results and various other studies have shown time and time again that this is not the case. And this is the 21st century. We've come a long way from the days of Marie-Sophie Germain, who in the 18th century had issues or had discussions with her parents who disliked her fascination with mathematics. They actually thought it was inappropriate for a woman to be so enthralled by numbers. She actually had to assume the alias Auguste Antoine Leblanc to apply to study mathematics at École Polytechnique. And she continued to astound mathematicians with advances in elasticity and number theory, despite being a woman. Some argue that her being a woman meant that her name is not included in the 72 names of French scientists inscribed on the Eiffel Tower. But this is the 21st century. And given that it is now accepted that women's brains are as effective and functional as men's brains, it's a cause of concern that such a state of imbalance still exists. I believe that this is having a huge knock-on effect on our capacity for innovation. And yesterday, with the presentation of the Women Innovators Award, and with the young ladies as well that we had on the Generation Z panel, I think that we definitely do have shining examples of women in STEM and what they can achieve. However, a lack of women in STEM, also known as MINT to German audiences, means a lack of talent in STEM. To remain innovative and competitive, we need talent, and we need our best brains and multiple perspectives on this most exciting part of human endeavour. Businesses need to be innovative, and many have spoken to the business case of having diverse workforces and boardrooms. Just this morning in the FT, I saw another article on a lady who's just become one of the first female partners at a law firm in the UK. It's still a topic that is debated a lot in the business world. And the pay gap is also a big bone of contention, which I must note is smaller in the STEM field when women start. And within their first 2 years, they're actually equally paid. The same applies to universities and their exploration of technology and engineering and what is physically possible. I'd argue that as academia and university tend to be more patient in waiting for ideas to form, waiting for research to be done, and waiting for significant progress to be made, they are, and they should, be taking this more seriously. Now, the patience exercised in academia and universities was driven home to me when I inquired about pursuing a PhD alongside my current career within investment banking. A PhD typically takes 4 years, and it was very quickly highlighted that within the 4 years it take me to study just one topic, that topic would definitely become irrelevant to the business with which I'm in. And until we have women well presented or represented in our research posts in university labs, adding their brainpower, perspective and experiences to our knowledge of computer science and engineering, as they now have in the arts and social sciences, we'll continue to miss out on proper innovation and technological advances being made in the 21st century. And missing technical women means missing the solutions we need to the problems that we have. Now, I run the STEMEX project in the UK, which is about exposing girls to women working in STEM and giving them the opportunity to explore the STEM skills that they need, but also the careers that they might be able to pursue. And so we end up working with a lot of girls, and when I speak to the girls, I always make it a point to show them examples where women have used their knowledge to solve big problems. I have 4 examples on this slide. The first is Stephanie Kevlar, without whom we wouldn't have Kevlar, which is what we need for bulletproof vests. We also have Eldorado Jones, who over 100 years after Carl Benz invented the first car, invented the engine muffler. Betty Nesmith Graham, known to some as the mother of one of the guys in one of our bands, whose name I won't mention, invented liquid paper, which is known as Tipex in the UK. And finally, Hedy Lamarr, star of Screen, and big Hollywood actress, actually invented spread spectrum communications and frequency hopping, which is what you're all using now in Wi-Fi. I also point the girls to examples where women sometimes are the answer for technology to make an impact. Hands up if anyone recognises who I'm stood next to in the top left-hand picture. No? For anyone who has an iPhone or an iPad, you may have spoken to this guy before. He's the voice of Siri. Yeah. And that didn't go down as well as it did when I showed the girls this picture, I must say. And the technology that we need to enable us to have Siri is voice recognition software, which has been around for decades, but which initially didn't take off because it was presented to typists and secretaries, mostly female, for whom the software hadn't been calibrated for. I also give the example of seatbelts, which were initially engineered and designed to the specifications of the typical man, his weight and his height. And so early editions killed women and children who used them. I want to show one more example of innovation led by women in a video.
Cyclists running the gauntlet of Paris traffic without a helmet. Many riders find helmets uncomfortable or unattractive and would rather risk a head injury than wear one. Even London's mayor sometimes bikes without protection. But a pair of inventors in Sweden hope to persuade the refugeeniks to think again. They've invented the Hövding, a discreet inflatable helmet worn round the neck. Co-inventor Therese Alstin said many Swedish cyclists refuse to protect their heads.
We've
developed Hövding primarily for all those cyclists that are cycling in traffic without any head protection, and that's around 80% of adult cyclists in Sweden.
The Hövding, the Swedish word for chieftain, has been tested rigorously. It's a simple puffy collar with a nylon airbag inside that inflates with gas in the event of a collision. Its release mechanism is steered by a sensor registering the cyclist's movements. The helmet inflates within 1/10 of a second, protecting the wearer before they hit the ground. It's also useful in investigating crashes, as Alstin's co-inventor Anna Haupt explains.
Hövding has a black box inside that registers and remembers the last 10 seconds of a bicycle accident, if one experiences one, and therefore we want people who have been in accidents and had their Hövding inflate to send it to us, so we can look at the information in the black box, which is of great interest to us.
Looking to the future, the inventors believe the Hövding idea could be developed in a variety of areas.
We think that in 10 years' time, Hövding will exist not only as a bicycle helmet, but also within other protection feature areas too. Horse riding, downhill skiing, hip protection for the elderly. Also, epilepsy helmets are very sought after, so there are many ways Hövding can be developed, which we will look into.
The product does have its downsides.
Thank you. We won't talk about the downsides this morning. Okay. So until we have, and those were two ladies from Sweden who have had a lot of grants actually from the EU, as well as other people to be able to develop that. So we are doing it in pockets. Until we have proper diversity of those working, studying and discovering in the fields of technology and engineering at university, and only half of the population is involved in furthering such exciting fields, we can only hope for half the innovation that is actually possible. In a world where economies are being driven by innovation and technology itself accounts for a growing part of every country's GDP, we all need to ensure that talent, irrespective of gender, background, age, or any other part of one's identity, is able to flourish. For me, the 21st century university will be a place where this can be realised and should be the home of such a possibility. The 21st century university is about giving youngsters like me and her the skills needed to discover, explore and learn before building careers in the world of tomorrow. So that's my take on the 21st century idea of a university. Now, the person who's actually giving this lecture is sat on that side of the stage and is Lord Chris Patten, who is the chairman of the BBC Trust, Chancellor of Oxford University and co-chair of the UK-India Roundtable. He's also spent his time in Brussels and shared a joke with me yesterday about maybe a Brussels joke. Some of you may have heard it before. What's the difference between Chris Patten and God? God is everywhere and Chris Patten's everywhere except Brussels. Didn't get a laugh from him, that's fine. Okay, it did. Chris was Chancellor of Newcastle University, from 1998 to 2008, and was elected Chancellor of Oxford University in 2003, which is, of course, my alma mater. And so I'm very honoured to actually have met my Chancellor and now to introduce my Chancellor to come and give this year's Innovation Union lecture. Thank you.